method. So augmented matrix, 1, -2, 1, 2, 4, 2. Do you guys know how to solve this? Not too bad, right? The first entry is already 1, so it's okay. What should I do? I need to eliminate 2 because my diagonal is that. What should I multiply 2 by and add to 2 what? -2 R1, right? Add to R2, give me new R2. So R1 stayed the same. 1, -2, 1. R2 changing. -2 times row 1. If it help you, -2 times row 1. Add to row 2, column by column. So -2 plus 2 is 0. -2 times -2 is +4, plus 4 is 8. -2 times 1 is -2, plus 2 is 0. Oops, something wrong. Hey, hang on. Oh, I forgot. There's a negative here. The second row, I wrote down the augmented matrix wrong. No wonder. So -2 times -2 is +4, plus your -4 is 0. What does that mean? You have all 0 in the bottom. If you would have rewrite it back, if you would have put x, y back, it would look like this. 1x minus 2y equal 1. And the bottom equation is just 0 equals 0, yeah? Right? What 0 equals 0 mean? Is it true or false? It's true, right? So that mean you have infinitely many solutions. Remember we did that a few lectures ago with the elimination method. Well, I'm gonna use the first. I had to continue. Remember, I asked you to use perimeter. Right, so I'm gonna solve for x. So x equal 2y plus 1. I'm gonna let y equal t, or t equal y, doesn't matter. Then x equal what? 2t plus 1. Do you remember that? Write your own solution in right up here. This is called overdetermined system of equation, right? Where you have so many solutions. If I would have asked you to give me a particular solution, just pick a point, any point you like. Maybe I'll pick 0, it's my favorite. 0 for t, then that's y, then x will be 2 times 0 plus 1, so 1. My particular solution, easy. Everybody have their own particular solution. So far, so good. I want you to try this one on your own, using Gauss-Jordan elimination as well. My advice to you, always have the first entry equal 1. Just make your life easier. It doesn't have to be, just make the competition a little easier. Let's take 17. It's not too late. So far, just leave it at fine. Oh, leave it there. Thank you, Michael. That's your quiz. You better get it right before Monday. It's in person. No, what I say. Determine the next one. I highlight the diagonal first, and everything underneath needs to be 0, starting with that one. How do I get rid of 3? Well, we're going to take -3 times R1, add to R2, give me new R2. R1 stay the same, 1, 2, -3, -2. R2 is changing. So -3 times row 1. If it help you, do it like this. And then add down, right? -3 times 1, -3 plus 3 is 0. It should be 0, because it will be 1. -3 times 2 is -6, plus -1 is -7. -3 times -3 is +9, plus -2 is -7. Oh, +7, I'm sorry. It's +9. -3 times -2 is +6, plus 1 is 7. It's a lot of 7. So far, so good. Yeah, so far, so good. That's the procedure. It's always like that. The next one, I want to eliminate the number 2. Any suggestion? How do I do that? Yeah. Good. Row 1, right? Because you don't want to do row 2. Row 2 is 0, right? It's not helpful. Yeah. Very good. I'm glad you speak it up so you remember things. All you do is find the negative number and add to it by multiply the some row by that number, right? -2 times 1, -2 plus 2, 0. -2 times 2 is -4. 4, -4 and 3 is -1. -2 times -3 is +6. -9 is +1. -2 times -2 is +4. -3 is +1. Oh, yeah, yes. -2 R1 plus R3. Give me R3. On your quiz, I do want you to do that as well. Because if you do something wrong, the grader can refer back, like, okay, he just make a arithmetic mistake, right? He didn't do it on purpose. But if you don't show me the step, I just assume that I can't read your mind, right? Just assume that you did it wrong. The keys here is keep your work clean for these problems. Right? So I'm gonna start a new matrix. I'm done. Right? I'm not changing anything. I'm gonna start eliminating this one.
Professor, I just have a
Yeah.
quick question.
Mhm.
For the equations, the system of equations we were using yesterday for one solution, they talked about flipping them. When we're working with the underdetermined and overdetermined systems, do you not recommend flipping them? Because when we were doing it on our own,
Oh,
I flipped it when you said it equaled 1 in my brain. That's what I.
oh, because I flipped because my first entry it wasn't 1.
Oh, I see. Okay.
Yeah, here it's already 1, so I'm okay.
So that's
Yeah.
what you're referring to.
Yeah.
Okay.
Mhm.
Thank you for that.
You're welcome. There. Now, in order to eliminate that -1 in green circle, there are 2 things you can do. Either you multiply the third row by -7, right, and add to row 2. You can't. You do not use row 1 again. Why don't we use row 1? What happened if you use row 1? You're gonna change this one, right? Because of this. Using row 2 is already 0 here, and it's 0 times anything is still 0. Add to 0, it still remains 0, which we try very hard to make it 0, right? So use row 2 to eliminate -1. Either you multiply the third row by -7, so you have +7 here, and add to row 2, so you got 0. Or you can divide the second row by -7, right? So either way, usually I just multiply a row, add to another row. I don't divide because sometimes we're lucky here because they all 7. But what if, like, hypothetically, one of them is like 5 here? Then you run into fraction, right? So usually all I did is just multiply the whole row by some number and add to another row. Right? So I don't run into fraction. So that's what I'm going to do. I'm going to multiply the third row by -7. Why -7? Because I need it to be opposite. Let me write out the step here. -7 times R3, add to R2, give me new R3. The row I want to change is row 3. Right. I'm gonna rewrite the first 2 rows so I don't forget. 1, 2, -3, -2, 0, -7, 7, 7. -7 times 0 is 0, plus 0 is still 0. -7 times -1 is +7, plus -7 is 0. -7 times 1 is -7, plus 7 is 0. 0 everywhere, right? Stop. If you have 0 in the bottom like that, do not do anything further. I know last lecture I keep doing the upper triangle, right? That's because my diagonal, they all number except 0, right? But here one of the entry for my diagonal 0, then you stop. Right? This imply if I would have rewrite this, put in x, y, z back. You don't have to, but let's do this. X plus 2y minus 3z equal -2. 0x, so I'm not going to write that. -7y plus 7z equal 7. And then the bottom is 0 equals 0. And because this is always true, you know that you have infinitely many solutions. Let me clean up my system's equation. Can I divide the bottom one by -7 or something like that? Or just 7? How about that? -y plus z equal 1. Okay. Just clean it up a little bit. Here's everybody's doing things different. we're gonna choose one of the equation and solve for one of the variable. The easiest one is the second one because it only have two variable, right? So I'm going to solve for let's solve for z equal y plus 1. So far so good. Why do we want to do this? Because the parameter, right? Now let t equal y. I suggest let t equal y but not equal z because it's just easier, right? You don't want to solve it back again. Let t equal y, then z equal what? T plus 1. You have two solutions already. You have y and you have z. So far, so good. You gotta remember the parameter t that I asked you to do. You can let t equal z if you like. Nothing wrong with that. If you let z equal t, then you have to subtract 1 from both sides. Then y equal z minus 1 or t minus 1. It doesn't matter. It's the same thing. I have y is t. I have z. The remaining variable that I need to solve is x. Let me go down here. Go down here. Let me rewrite that. X plus 2y minus 3z equal -2. I have y. Y is t. Z is t plus 1. Now I can solve for x. Move everything to the right except for x. So plus t plus 3. On the right hand side, that's cancel. That's cancel, right? So x equal t plus 1. That's why we use parameter t. It's everything based on t. X or z, y or z. It's confusing. Let me recap. I see a lot of eyebrow churning. Let me recap. The first step, solving infinitely many solution problem, is pretty much the same with one solution, right? You use Gauss-Jordan elimination. Determine your diagonal slowly. Eliminate numbers underneath it. If an infinite many solution, your last row should be all 0. Okay? If an infinite many solution, then you stop. You're gonna put x, y, z back. Clean it up if you need to. Then pick a variable. Pick one solution and then solve for one of the variable. Let t equal one the variable. Pick your favorite. Doesn't matter which one. I pick y equal t here because it make my calculation easier. If someone, don't write this down. If someone in the beginning have solved y for y, say y equal z minus t1, right? Then someone might let z equal t, right? It's just easier for their calculation. It's the same thing. What I'm saying is there's no one way to do this. But pick your way. Once you have your way, t equal y, slowly put it back to solve for another variable, right? Just backtrack, so I backtrack. And you have more. If I were to write this in order pair, x will be t plus 1. Y will be t, like I defined it earlier, and z is t plus 1 as well. So I just did 2 problems that have infinitely many solutions. This is 2 by 2, this is 3 by 3. We'll never ever do 4 by 4. That's a good thing. Next, we're going to take a look at the system of equation that has no solution. This is the easiest between the 3, so that's good news. The first step is pretty much the same. You use Gauss-Jordan elimination, so put it in augmented matrix and do what you need to do usually. 1, 1, 1, line 1, 3, -1, -1, 4, 1, 5, 5, -1. Determine your diagonal. It helps in terms of visualization. You don't have color, you can just circle it. My first entry is 1, so I don't have to flip anything. Right. Eliminate 3. At this point, somebody should tell me what to do. Kobe, you want to give it a shot? And the second row change, right? The first one stay the same. 0. Let me do like this. And add down. -3, -1 is -4. -3, -1, -4 again. -3, +4 is 1. Someone tell me how to eliminate that 1 on the third row. Kobe, you want to keep doing it? All right, good. So you got the idea, right? Negative R1, add R3, give me new R3. It's very repetitive. So 0, -1, +5, 4, -1, +5, 4, -1, -1, -2. That's my diagonal. Keep going. Oh, this is easy. What should I do next? What row should I use? For the last entry, or the last from the bottom, right triangle. Okay, go ahead. That's it, and we're done, right? So R2 add R3, give me new R3. Thank you. The first 2 rows stay the same. 1, 1, 1, 0, -4, -4, 1. 0, -4, +4, 0, 0. And the right hand side, 1 minus 2 is -1. You see something wrong with the last row. You would have plugged X, Y, Z back. You plug it back. Is 0 equal -1? No, right? No, 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 false. And you stop, you're done. That's why I said it's the easiest one of the three. No solution. Empty set. Yeah. You can use either conclusion, either notation, or write out. I want you to try this. Oh, you know, I'll do this with you. Ooh, this is 4 variables. Oh, yeah, sure. This one.
Yeah, I just want to see, the second row after. Okay.
Mhm.
I just wanted to see if I was.
Okay. Yeah. This one. One, two, -3, 1, -2, 3, -1, 2, -2, -4, 1, 2, 3, -5, 1, -3. When you see something like this, you have more variable than rows. It's likely that you run into infinitely many solutions. The reason being because you have things called free variables. What do I mean by free variable? If you go back to the problem where they have infinitely many solutions, remember I let y equal t? Y is a free variable, right? You can choose any, it's free because you can choose any value for y, and x and z depend on that, right? It's free. You can choose any value for y. Let t be anything. All right, let's do this. Gauss-Jordan elimination. Diagonal. There's no correct diagonal, but I'm gonna make one regardless. I know, look weird. But, so eliminate 3. Same thing. -3 R1 F2 R2, give me new R2. Zero. Something like this. -6, -1, -7. +9, -2 is +7. -7. +6, +1, 7. I feel deja vu, which is similar to the one we did earlier. Same thing, next step. You take -2 times R1, add to R3. Everybody should be pro by now with these first few steps. 0. Negative 4, 3 is negative 1. Positive 6, negative 5 is 1. Negative 2, 1 is negative 1. Positive 4, negative 3, positive 1. So far, so good. Last one, the last entry, which is this guy. I'm going to multiply the third row by negative 7 like we did earlier. And add to row 2. Negative 7 times 0 is still 0. Add to 0 is still 0. Negative 7 times negative 1 is positive 7. Add to negative 7 is 0. Negative 7, 0. Positive 7. Add to negative 7, 0. And 0. Sorry, we have infinitely many zeros. Clean this up a little bit. Oh, sorry. When I say clean up, I meant divide both sides by negative 7. So I have y y minus z plus w equal negative 1. Okay, the problem, let's pick the simplest equation and solve for one of the variable. I'm gonna solve for y. So if I call this equation number 1, equation number 2, so 2, y equal, move everybody to the right, so equal z minus w minus 1. So far, so good. Now the problem is usually I only have one variable, so I can let like either like z equal t or w equal t something, but you have 2 here. It's the same thing, meaning you instead of one free variable, you have 2 free variables. So I'm gonna let t equal z and pick a different Roman letter for w. S equal w, where t, s are parameter. They are also free variable. Here parameters corresponding to free variables y and no, sorry, Z and W. Respectively. Just note. Just note, yes. Mhm. Yeah, so that I don't have to do on the exam. Does that make sense? 'Cause it's a longest one. But you have something like this on the exam. Remember, exam more important than the quiz. Okay. Okay. So I have T is Z, and then S is W. Plug it back to find Y in terms of parameters, right? Then Y equals Z is T, W is S. So you have, let me circle the solution. That's my solution. Another one. So 3 so far, right? 3 so far. One more to go, the X. The X, you're gonna refer to the first equation. Let me copy that down. X plus 2y minus 3z plus 1w equal 2. Negative 2. Well, you know why? Y is t minus s minus 1. Right? Z is t. Z is t and w is s. Oh, I should have said s. Sorry, I keep that's w. What is? Remember, you solve for x, right? Let me give you a happy ending. I don't want to keep you let me give you a happy ending. If you clean that up, x equal s minus s plus t. Yes, that's it, x plus t. In order, s plus t, t minus s minus 1, t w. By the way, the letter T and letter S are just letter. Okay, you can, if you don't like S, you can use U. U equal W. It doesn't matter what letter. T, S are very common, so I just use that. Let me give you one more. Bear with me for like a few more minutes. It's a no solution. It should be fast, and then we'll be done. So the problem we just did, it had more variable than rows, right? Here, the opposite. You have more rows than variables. Gauss-Jordan elimination. 1, 2, 4. It'll be quick. 1, negative 1, 0, 4, 3, 12. Well, it's so difficult to determine your diagonal now. I cannot move. Just stop right there, right? Eliminate 1. That's easy, right? Negative R1 add R2, give me new R2. 0, negative 3. -4. Keep going. Eliminate 4. I'm not sure I need that, but let's do that. So I take -4 times R1, add R3, give me new R3. 0, -8, 3 is -5, -16, 12 is -4. That's my diagonal. I still have to eliminate -5. So what I'm going to do is I'm going to multiply both rows, second row and third row by something, add them together, right? Because 3 and 5 are not very, they're both odd. So so what do? I'm gonna take 5 times R2, add to -3 R3, give me new R3. So let me, so 5 R2, add to -3 R3, and then add. Should be 0. I know this guy should be 0. 5 times -3. 5 times -3 is -15. That, and then -5 times -3 is +15. You add them together, it's 0. Second entry also 0. Now the last one, 5 times -4 is -20 plus 12. It's not 0. We know that much, right? I couldn't think. -20, +12. 8, -8. Can we stop here? Yes, right. You have a left-hand side 0, and the right-hand side is some number. So from this here, 0 equal -8, and you say false, and you're done. I'm going to construct extra credit. You should see it in a few minutes. Okay. That's it, done. Yes.
As long as they're getting close to tonight.
Yes. I'll tell you what. I'm probably gonna stay up late and grade the exam. You should have by morning of Saturday. Okay. Mhm.
Also took the last page.
Oh, well, that was you. I'm sorry.
Yeah.
Why didn't you say anything?
Oh,
I didn't know your face.
No, it's okay.
Oh, that's why I look at you. Oh, you didn't look familiar. I'm so sorry. Waiting. Okay, so here we can stay here. You want to review it before so these are the 2 questions that relate to the.
Okay.
So you want to review it?
I already
first?
reviewed, just right there. like 5 minutes.
Oh, okay. Take a look at these objectives because
Oh, okay.
the one I'm about to give you is very similar to
Okay.
these.
Okay. All right, thank you.
You can pull up class note from me. When you're ready, let me know. Okay. You're welcome. What's your name, though?
Oh, Nicholas?
Nicholas. Thank you, Nicholas, for coming. Thank you. You too.
Thank you.
Do you have workshop today, Nicholas?
I do, yeah,
1:20?
yes.
Okay, I'll email Sarah, okay? So you'll be fine, yeah. She won't, is there a drill or,
You said you're on it, who's our Monday now?
oh, okay, okay. Let me email her.
Oh, thank you.
Yeah, no, sorry about that. I didn't know it was you.
Oh, no, it's all good. I didn't wanna
Otherwise, I
interrupt
will
the
let you.
class.
You ready? You are Nicholas Williams, right?
Yes.
Okay.